silence filled with secrets. The night sky looks peaceful, a dome of stars, a glowing band of the Milky Way, distant galaxies painted like faint brushstrokes across the black canvas. To the human eye, it feels calm, a perfect silence, a sanctuary beyond Earth's noise. But this stillness is an illusion. Space is not empty, and it is not quiet. Every point of darkness hides movement. Every breath of silence is saturated with invisible radiation, drifting particles, and immense forces twisting space-time itself. To stand beneath the stars and feel safe is like standing at the edge of a stormy ocean, hearing no sound but knowing waves of unimaginable power roll beneath the surface. For thousands of years, humanity has gazed upward and found comfort in this illusion. Ancient cultures mapped constellations, told stories of gods and heroes, believing the heavens eternal and unchanging. Even in the scientific age, the universe often seemed like a stable backdrop, vast, indifferent, but constant. Now, that illusion is fading. The 21st century has given us a new observer, not human, not limited by tired eyes or slow thoughts. Quantum artificial intelligence. Unlike telescopes that merely collect light, unlike scientists who interpret data through human filters, this machine consumes oceans of information and finds patterns no mind could see. And what it finds is disturbing. Where we see stars glittering like jewels, it sees unstable furnaces on the brink of collapse. Where we see black velvet emptiness, it sees radiation, threats, predators moving silently through the void. The silence of the cosmos is not peace. It is camouflage. The question is, what happens when something finally learns to pierce the veil? The birth of a new cosmic observer. Astronomy has always advanced alongside technology. In 1609, Galileo lifted a small telescope and shattered the old view of a perfect heaven by finding moons circling Jupiter. In the 19th century, spectroscopy revealed that stars were not mystical fires, but suns burning hydrogen and helium. In the 20th century, radio telescopes uncovered pulsars, quasars, and the faint echo of the Big Bang itself. Each leap brought us closer to truth, but each also revealed a deeper mystery. The 21st century, however, presented a new challenge: too much information. Modern observatories from Hubble and James Webb to massive radio arrays like LOFAR and the Square Kilometre Array generate petabytes of data every year. Every star flicker, every gravitational lens, every pulse of radiation is recorded. But no human team can process it all. The universe has become a puzzle too vast for us to assemble. Quantum AI was built to solve this. Unlike classical algorithms, it doesn't just search for predefined patterns. It discovers. It compares billions of light curves, maps galactic rotations, and cross-checks gravitational anomalies with the precision of a million scientists working in unison. And it does so in moments. Already, it has achieved the impossible. Detecting exoplanets smaller than Earth by subtle variations in starlight. Mapping dark matter by analyzing gravitational lensing across thousands of galaxies. Predicting asteroid trajectories centuries ahead with near-perfect accuracy. Reconstructing incomplete cosmic signals, turning apparent noise into coherent structures. But with these victories came unease. When AI was fed NASA's newest Atlas images of deep space, it did not simply catalog stars and galaxies. It began flagging regions where something strange was happening. Places where radiation spikes aligned in ways no natural process could explain. Zones of gravitational distortion without visible mass. Streams of particles with no identifiable source. To human eyes, these were statistical errors, random fluctuations, or background noise. To the AI, they were patterns precise, repeat, undeniable. It was as if the universe had been speaking all along, and only now, through the cold eyes of a machine, had we begun to hear it. Rogue black holes, the invisible predators. While investigating gravitational anomalies, the AI uncovered signs of invisible mass moving through star fields, the telltale fingerprints of rogue black holes. These wanderers, flung from galactic collisions or supernova kicks, drift unseen across interstellar space. For years, astronomers assumed they were rare, but the AI suggests the opposite. The galaxy may be littered with them. Dozens, perhaps hundreds of rogue black holes within striking distance over cosmic timescales. The danger is subtle but immense. A rogue passing near our solar system could distort orbits, destabilize comets in the Oort cloud, and send a rain of icy missiles toward Earth. Closer still, it could strip Earth from the sun's embrace entirely, leaving our world a frozen orphan drifting in darkness. They are the ultimate predators, silent, invisible, unstoppable. Solar fury, a familiar threat reimagined. Even our own star is not safe. Solar flares and coronal mass ejection CMEs are familiar hazards, their beauty seen in auroras dancing across polar skies. But the AI detected long-term cycles in solar activity that defy current models. TS simulations predict storms far more powerful than the infamous Carrington event of 1859. Storms capable of crippling satellites, erasing power grids, and throwing our digital civilization into chaos. In a world where everything depends on fragile electronics, such an event could mean global paralysis. The unsettling truth: while we fear the distant void, one of the greatest threats to our survival may already burn above our heads. Cosmic rays, the invisible knives. You are being pierced right now, not by bullets, not by beams of light, but by cosmic rays. High-energy particles traveling close to the speed of light. They come from every direction, born in the most violent events the universe can produce. Most are harmless, stopped by Earth's atmosphere or deflected by its magnetic shield, but some penetrate, reaching the ground, even cutting through your body as you listen. A single proton, accelerated by a supernova millions of light years away, can strike DNA like a knife. For decades, cosmic rays were considered background noise, something scientists measured but rarely feared. Now, quantum AI tells a different story. By analyzing millions of particle detections, it discovered disturbing patterns. Streams of radiation that do not point to any known astrophysical source. Sudden bursts aligned with distant gamma-ray events, as though the cosmos itself fired volleys in coordinated rhythms. A subtle, but measurable increase in the flux of ultra-high energy particles striking Earth in recent decades. The implications are unsettling. For astronauts, cosmic rays are lethal companions. Long missions to Mars or beyond mean constant exposure. Cancer risk rises, DNA breaks, nervous systems fail. On Earth, Airline crews flying at high altitudes already receive higher doses than those on the ground. But the AI's deeper fear is evolution itself. Cosmic rays, by shattering DNA, may have shaped the course of life on Earth. Extinctions, mutations, sudden evolutionary leaps all may carry the fingerprints of invisible visitors from the stars. What once seemed random is now mapped with eerie precision, and the message is clear. The universe is not a safe cradle. It is a battlefield of radiation, and we are fragile organisms, surviving only by chance. Cosmic rays showed us how fragile we are, but the next discovery is even more disturbing. Part 2. The Ghost Particles. Coming soon.